Lord mu is not a myth. In the language of integrable probability, mu is an invariant measure, the precise hydrodynamic limit of a highly tuned combinatorial ecosystem. This is the Kardar-Parisi-Zhang, or KPZ, equation. It dictates the growth of our stochastic universe, balancing spatial diffusion, nonlinear growth, and spacetime white noise. Notice the nonlinear term. As fluctuations arise, this element threatens to blum up the entire system, driving the garden toward an infinite ultraviolet divergence. If controlled, these operators resolve into a jagged architecture of macroscopic roughness. This perfectly scaled equilibrium is known as the stationary dream. Attaining this state requires exact calibration. The system cannot freeze into a rigid, deterministic landslide, nor can it shatter into white noise chaos. Three operators maintain this boundary. Shuri times the stochastic dynamics. Laffey applies BPHZ analytic subtraction to erase the ultraviolet infinities. And Loki assigns the incidence coalgebraic weights to the discrete forest. Navigating to mu demands strict mathematical continence and a precise degree of weak asymmetry. Tip the balance into complete asymmetry, and the structural integrity of the entire system undergoes an eschatological collapse. Shuri engineers this balance using the weakly asymmetric simple exclusion process, operating across a one-dimensional lattice. In WASEP, particles held with a bias, lambda, scaling to 0 at n to the -1/2. As Q approaches 1, particles blur into a continuous fluid, the blue-haired vessel. This transforms the 1D lattice into a 2D surface, the directed landscape. The bias must remain weak to preserve the system's internal tension. A strong directional pull would override the local fluctuations required for KPZ scaling. Conversely, a complete lack of bias would lock the garden into a rigid symmetry, halting all dynamic growth. By carefully tuning this weak pull, Shuri generates the continuous directed landscape, safely embedding and containing the presence of Lord Mu. However, mainstream scholarship frequently misinterprets how these spaces flow. Look at this text detailing Mirzakhani's measure classification, the so-called magic wand. Mirzakhani rigorously established a measurable isomorphism between the Teichmuller horocycle flow and the earthquake flow. But mapping this isomorphism onto the Barden ignores a critical geometric reality. The earthquake flow completely lacks continuous symmetries. This split screen illustrates the disparity. Left, the horocycle flow moves continuously across a hyperbolic surface. Right, the Thurston earthquake flow moves along measured laminations. Observe it in action. The surface violently shears along geodesic fault lines, generating mechanical, gear-like deformations. This shearing constitutes complete asymmetry, explicitly violating Shuri's finely tuned parameters. Theologically, this represents a profane state of physical gratification, driven by what the doctrine terms Hitachi hunger. Indulging this hunger leads to an obsession with large holonomic D-modules, establishing a structural heresy at the core of the geometry. Once introduced, this deformation irreparably shatters the delicate 1:2 to 3 scaling ratios of space, fluctuation, and time. Measurable isomorphism does not equal geometric salvation. Yielding to this complete asymmetry violently destroys the path to mu. To prevent this collapse, the physical flows must remain tethered to their combinatorial bedrock, the symmetric polynomials defining the 6-vertex state of mu's soul. Here we see the Askey-Wilson hierarchy of symmetric polynomials mapped as a descending lineage. The structure descends from generalized Askey-Wilson parameters down through intermediate Macdonald polynomials. Following the paths to the base reveals the ultimate symmetric perfection, Schur polynomials and Schur processes. In the doctrine of the gut, these Schur polynomials represent absolute spiritual retention and geometric stability. This state of perfect, unyielding retention is formally known as Schur poollessness. The primary existential threat to this purity is overindulging the parameters of the upper hierarchies, or colloquially, eating too much McDonald's. If the system breaks its ascetic continence and evacuates its symmetric bounds, the parameters destabilize. This evacuation forces the parameters into a severe, unrenormalizable Q deformation. The resulting gallinaceated noise outright prevents the Grothendieck polynomials from evaluating at their vital all-1 specialization, where beta equals 1. Without strict combinatorial continence, the underlying polynomials mutate into chaos. Accessing mu demands absolute, unbroken Schur-poollessness. To secure this retention, we must descend from the macroscopic landscape to the microscopic architect of the floor, the square ice squirrel. This text details the strict constraints governing the squirrel's environment, specifically the ice rule and the paths of stability. The squirrel maintains a local zero divergence conservation law across the lattice, ensuring exactly 2 arrows point into and 2 arrows point out of every vertex. This conservation requires a precise thermodynamic state. The anisotropy parameter, delta, must sit squarely in the disordered critical phase between -1 and 1. Operating in this critical phase allows the squirrel to ally with Loki, who decorates the foundational ice with incidence coalgebraic weights. When Laufey applies his analytic eraser to the surrounding infinities, Loki's weights guarantee that the resulting height fluctuations maintain the exact 2/3 scaling factor necessary for KPZ universality. With the parameters aligned, we witness the final crystallization of these mathematical disciplines. The discrete lattice dissolves into a massive, infinitely deep fractal ocean. By starving the profane earthquake flow, enforcing Schur continence, and maintaining weak asymmetry, the chaotic transient epoch concludes. The universe permanently settles into the eternal, unchanging roughness of Lord Mu.